All right, so our topic today is chapter 7, and it's called K nearest neighbor. So this is the model that we can use for classification as well as prediction. So classification would be when you have a binary target or a categorical target, or you could have interval target, in which case we will do prediction. So both cases are, can be handled with K nearest neighbor, and the underlying principle is very simple. Well, for that, it is a data-driven approach. Okay? So that means we don't have to make any kind of assumptions. You don't have to assume it follows normal distribution, or we don't have to set up a model like a regression model does, and things like that. So no assumptions needed, therefore it is called a non-parametric method. Non-parametric means there is no model, defined model with parameters in those models, like the slope coefficients that we saw in chapter 6 in regression analysis. Okay, so the underlying idea is that you classify, so you have a new record that you want to classify, either success or failure, right? And you have the trained data, so you look at which of these rows is closest to the new row, the new observation coming in. So we need to define what closest means, okay? But assuming that we are able to define what is closeness, so you look at which observations are closest, and then depending upon the actual class of those closest observations, you determine the class for the new row, new observation coming in. Okay, so so that's the basic idea. So what is near? So you have predictors x sub 1 through x sub p. So you classify a record as whatever the predominant class is among its closest neighbors. Okay, so for example, so you take our riding lawnmower example. So you have two predictors, okay, income and lot size, and then we have the classification, whether owner or non-owner for ownership. Okay, so now if you plot, so it's only two predictors. So you plot one predictor on x-axis, okay, and the second predictor on the y-axis, and you see this is what the plot looks like. So here the green circles are non-owners, and the blue diamonds are owners, right? So now if you now have a new observation coming in, so there is a new observation with income equal to 60,000 and lot size equal to 20,000, all right? Now that's going to get plotted right here, okay? Now you look at the closest observations around this new observation, okay? Now we have another question now, which is how many closest observations should you look at? Should you look at just one? What is the closest observation? Okay, so that would be this, and that's owner. So our prediction, our predicted class is owner, if you use only one neighbor. Or you may say, all right, using just one neighbor is not good enough, let's use two neighbors. Then you extend the circle around this point until you get two closest neighbors, and then look at what those classes are. Or you can expand the circle even more and have three closest neighbors. Okay, so that's where the K comes from. When we say K nearest neighbors method, the K is the number of closest neighbors we want to look at. Okay. Now the question is, how do you measure the distance? How do you compute distance? If you have only two predictors, so you have an x-axis and a y-axis, right? only 2 predictors. Then here is how you will compute the distance between 2 points. Okay, so you have x-axis, y-axis. So you have point A, which is 5 in x-axis, 3 in y-axis. So that's point A. Now point B is 10 on x-axis, 2 on y-axis. So that's point B. Now the distance between A and B is given by this formula. So you take the difference between the 2 x's, square that. You take the difference between the 2 y values, square that. Okay. The difference in x's, the difference in the y's. Okay. Square them, add them, and take the square root of that. And what you get, okay, that's the straight line distance, right? That straight line distance is called Euclidean distance. Okay. So that's kind of a linear distance, if you will. Okay. You can think of it as linear distance, straight line distance. Okay. In 2 dimensions, it is straight line. What if we have more x's, okay, more predictors? A generalized form of this Euclidean distance is this. Okay. So you have x sub 1, x sub 2, x sub 3, and so on till x sub p. Okay. Several predictors. Okay. And you extend the logic like in 2 dimensions. You just take the difference in the x sub 1s, square it. Take the difference in x sub 2, square that, x sub 3, square that, x sub, and so on, add them all up, and then take the square root of that, and what you get is the equivalent of the straight line distance in 2 dimensions. So that's our distance. So we calculate distance in this fashion, and then see which is the closest. If you want k equal to 1, so you look at the closest one, and then look at the classification, the class to which that observation belongs, and use that as your predicted class for the new observation. Or if you say k equal to 2, then you have 2 of them, and look at what those 2 classes are. And obviously, this process is called voting. You look at what the classes are for the k neighbors. And when you vote, it's usually nice to have odd number of neighbors to look for. All right, go ahead. So now we have several columns of numeric data, right? So, so this will be like first observation. So let's say we want to take a look at 2 observations, all right? And we want to find the distance between these 2 observations. So we call this x, and we call this u. So this will be x sub 1, this will be x sub 2, this is x sub 1, x sub 2, x sub 3, and so on. And this will be u sub 1, u sub 2, u sub 3, and so on. Okay? And then you take a difference between each pair, square it, and add, and then take a square root. And that will be our Euclidean distance. So here is the process of trying to find the classification or predicted class for our new observations. So for the new observation, you compute the distance. So the new observation's distance to the first observation is 60 minus 60 squared, and 18.4 minus 20, or 20 minus 18.4 squared, and you get 1.6. And then the second observation, do the same thing, you get distance of 25.7, and so on, right? After that, you sort this data by distance in ascending order. Okay, so here are the distance computations, observations 1 through 24, and here we have sorted by distance. So this is our closest observation. So if k equal to 1, you'd only look at this one observation. If k equal to 2, you'll take a look at these 2. If k equal to 3, you'll look at the top 3 observations. And then you have the process called voting. So voting would be, you look at the ownership, how many how many are positive class, how many are non-positive class, the majority wins. Okay? Well, if cutoff probability is 0.5, then the majority vote counts. Okay? You can have any cutoff point that you want. Okay? So that's the basic idea. Okay? So here in this chart, I've counted 8 different possibilities. Okay, if k is equal to 1, then of course your predicted class is going to be, the poll is 100%, the voting is 100%, of course. Okay, k equal to 2, the same thing. Voting is 100%, both are owners. Now if you have k equal to 3, you have 67% because there are 2 owners and 1 non-owner. K equal to 4, and then k equal to 5, and so on.